Hello, I'm Mike McCulloch. Today I'd like to talk to you about Mach's bucket, which you may or may not have heard of, but it's very interesting because you can, depending on the conception, you can see the entire universe in one bucket. So imagine you take a metal bucket and you fill it with water and you attach it to a rope and suspend it from, say, a tree branch or something like that. And then you let this bucket full of water spin. So you spin it up and you let it go and you watch it spin. Now, at first, what will happen is that the wall of the bucket will move first, and then by friction it will start to spin the water within it as well. And you'll notice that as time goes on, the water will try to go in a straight line as it's spinning because of inertial mass, and so it will start to pile up around the edges, trying to escape from the center, following a straight line, following Newton's first law. And eventually the surface of the water will be concave, so it'll be lower in the center than it is at the edge. So Newton discussed this in his work, and he said that what's actually happening is that the water is feeling a rotation with respect to absolute space, what he knew as absolute space, which is like a grid that things determine their position relative to, that he imagined. But people like Leibniz and later Ernst Mach, they said that this was a very bad idea because absolute space is a thought thing. It's something that you can imagine, but you can never actually measure. You can't measure it directly. So they said this was a bad idea. And what Ernst Mach said, is that what's happening is that the water is spinning with respect to things that it can know about, and that must be matter, other matter in the universe. Now it can't be the matter of the bucket itself, because at the beginning there was no effect when the walls of the bucket were spinning and the water was still flat before it had started to move. So Mach said, if we rely on only things that we can measure and see, which is the correct way to go in science, that's always been proven, then we have to say that the water is spinning relative to every other piece of matter in the universe. And so that is why it is trying to continue in a straight line, because it's relating its position to everything else in the known universe, or the other matter in the universe. But Mach then said something very interesting. He said, what would happen if instead of spinning the bucket, we were to take the entire universe and spin that around the bucket? What would happen then? And he said that nobody is competent to answer this question. Physics at his time does not go that far. It does not say what would happen. But I think with quantized inertia we can say what would happen for the first time, because okay, so taking the spin of the bucket itself first, then what happens in quantized inertia is that you spin the buckets, the water starts to spin. That means that the acceleration of the water and the bucket as well, but mostly the water, relative to every other mass in the universe is increased because they're mutually accelerating now. So in quantized inertia, that means the inertial mass of the water goes up, and that means it will, in order to conserve momentum, that means it has to slow down a little bit relative to the fixed stars, so there'll be a certain resistance there. Okay, so that's the answer for the bucket itself. How about if we keep the bucket steady and we spin the cosmos around it? Well, then the same thing would happen. You see, you'd spin these stars around the bucket, the mutual acceleration between the water and the stars would go up, the inertial mass of the water would slightly increase because of in quantized inertia, and this means that to conserve momentum it would have to slightly follow the fixed stars. So now we've answered the question, Mach's impossible question. We can speculate about what would happen, but we can do more than that, because there have been some tests done. So Martin Timar did some experiments. He had gyroscopes and he span supercooled disks near to them, and he found that the gyroscopes span with the disks very slightly. And as I discussed in a previous video, quantized inertia predicts this really well, and it even predicts an asymmetry in the results. So this is direct evidence of what I've just said, that quantized inertia enables us to answer this question. There's also the flyby anomalies, where spacecraft flying by the Earth, depending on the orientation with respect to Earth, seem to move at different speeds. When they're in a position such that the mutual acceleration between them and the Earth is larger, then they tend to slow down. And when along the axis, the spin axis of the Earth, it's smaller, they tend to speed up. And this again is direct evidence for this. So this means that you can see the cosmos in a bucket of water. That's one thing. The second thing is that quantized inertia predicts something that standard physics cannot. And furthermore, that has been experimentally confirmed by these two experiments. Okay, so I hope you've enjoyed this video, and I look forward to speaking to you next time. Goodbye.